I get excited making CNNs because, it's really like making elite models. All right, so we did it a little differently, like when we were looking at the slides, and you know, the number of parameters. I mean, over 200,000. That's a lot, and we only used a subset, like 2,000 rows. So this could be like a little costly. So let us try now this max pooling 2D option. Let's see, what does that look like? How do we do that? Well, we've got to get it in there, right? Like these different imports. If you haven't imported it, it's not in there. And it's not the initial thing, right? So it's most likely a layer, and it is a layer. So in addition to flat and right, MaxPool 2D. You may wonder why 2D and not 3D. I mean, in effect, everything we're doing is two-dimensional. It's just like this. That's what this one is indicating. Well, let's do it here. Okay, after we do the convolution, let's cut down on the size, right? And so you've got these, it's like 32 different grids. We can cut the pixels, cut it in half. And the way you do that is model.add, put in parentheses. Well, what do you think here, right? What did we just add? We added max pool 2D. And the shortest way to do this is you can just put in a 2 in parentheses. Okay, and what that'll do is it'll narrow it down by half, but when it's 2 by 2, it's almost like a square root, where 16 by 16 becomes more like a 4 by 4. Okay, and we can just see it. Like we could just do this by itself and see. Okay, add max pool layer. Or we could keep going, right? Like we could do, like say, hey, we cut it down in half. Should we add another convolution? Let's try it. Okay, so if you add another convolution, let's do it. Add new convolutional layer. Convolution, cool name, right? Convolutional layer. And see if you could do it on your own. Can you add a new convolutional layer on your own? There are some free parameters. Okay. I think you can. Go ahead if you can. If not, I'll jump right in. Model.add. Well, same thing. It's conv2D. And last time I had 16 filters. Maybe I want to keep narrowing down a little bit, so I'll pick 16. And the kernel size. Should the kernel size be? Well, you can actually choose, right? So you could do another 3 by 3. You could do 2. You could do 4. There's not really a right answer. I think 3 and 2 are the norms here. Note that if you do a smaller kernel size, you can end up with more data. So if it's less data, maybe I'll keep it at 3. Keep the activation equals ReLU. And then you know what I'm going to do? I'm going to do another MaxPool 2D. Because I'm modeling what we showed in the slides, and it's just nice to like cut down on the size of the number of parameters. That's in effect what that's going to do. So by the time we flatten it, it's going to end up with a lot less parameters. Now it still could be a lot of parameters, and that's why we keep this model.summary. We can see and make adjustments accordingly. Okay, so what do we do here? Added MaxPool 2D, 2. Added a new convolution layer of 16 filters, also with the kernel size of 3. We don't need the input shape because it's not the first one. It can gather it from the previous one. Did the MaxPool again, just trying to not go crazy with the parameters, and then flatten it, and then everything else is the same. I'm excited to run it and see how it does. Okay, you ready? Shift enter, fix it. Sometimes you get an error. It's okay. Like go back and look. It's often like a little thing, like maybe you left off a parentheses or something. Like look at that, 3 parentheses here. This one is 2. Okay, errors are going to happen. You can always pause the video as well if need be. Okay, shift enter. And remember how many parameters there were before? Well, look now, there's only, last time was over 200,000, now there's 9,000. That's a huge cut down. You see how max pooling, what it does? See how it cuts it in half? Right, that's the idea with the 2. Okay, it's cutting it in half, and you could cut it down even further. Now, how's the accuracy doing? Is it going to suffer? Well, it takes a little longer to build up, but you can see it did build up to 99, so quickly build up. And note that in this case, the accuracy is in fact better. It is 97.6%. So it is not overfitting as much. Okay? So that is a nice step in the right direction. I think this is a cool model to kind of go with. You know, you could try like, little things like for a little more specificity, like what if I change this to 32, or what if I change the kernel size to 2, that type of thing. And we will look at fine tuning this. But what I want to do to close out this lecture is I want to go back to the top. And I want to take out the number of rows and do it on the full data set. By the way, this is not actually the full data set, it's a subset of it. So there's an even bigger data set. Okay, let's see now how the model is going to do. And you can ask yourself too, what do you think it's going to do? Do you think scores are going to be better or worse? Or it's going to have a lot more data, so depends on how you look at it, right? Is there more to get wrong or more to get right? So to runtime run all, the restart you could or could not. Like, it doesn't really matter sometimes. I just like to keep my numbers sometimes, straight. And I think it's always fun, by the way, to see what is it going to print out. It's a 2. And you can quickly jump down. You can see now it's got 20,000 rows here instead of 2,000. So it changes by a factor of 10. Now it's still got that number of parameters. And then when you look at it, you can see it does take a little more time to run. Okay, so during lecture, do we wait for it? Well, let's just wait for a little bit and see how the accuracy compares to before. The epochs here are, I should say, the accuracy. Yeah, it goes. Notice how it always does this. It goes up really quickly, so it's quickly like optimizing parameters, and then it just starts to get like better and better, in general. So what we'll do in the second half of today is we'll look at, okay, what can we do to make additional adjustments? What are techniques that can be done to fine-tune CNNs besides what we've looked at? What we've looked at has been doing things like adding max pooling layers, which cut down on the number of parameters, and they also provide some regularization because it forces more generalization. Okay, and then also changing, of course, the number of convolutional layers and the size of the kernel. Okay, I'm going to pause the video because you guys have the code, you're running it. Will it do better than the 97%? I'm excited to see, and I'm sure you are too. Keep up the great work.